Okay, greetings to everyone. I hope everyone is doing fine and is healthy during these hard times. To supplement your syllabus, we have decided to come up with a series of video lectures, and today I'm going to start the first chapter of class 12, or rather the first unit of class 12, and the chapter is named as Electric Charges and Fields. The chapter is named as Electric Charges and Fields. Now this word, charges, this is not something new to us. We have come across this word, charge, in class 10, and even if somebody has not reached class 10 also, he has heard this word. Charge, discharge, we keep on saying it without really understanding what it is. But the first chapter of your syllabus for class 12 deals specifically on charges and the environment they create around themselves. Next is fields. It's not a playing field, it's a gravitational field. It may be an electric field or electromagnetic field, to be in the true sense. If you note the word static, static has a meaning. Its literal meaning is that something is stationary. Okay, something is stationary. Here, static means the charges that we will deal or the charges that we will study will be stationary. They will be at rest. So this is the first point that you have to note. Electrostatics is the study of the electrical environment of a charge that is stationary. Okay, the charge should not move. When the charge moves, it's a different field altogether. Now, why I have written gravitational force in the chapter electrostatics or electric charges and fields? You can see two columns here, gravitational force and electric force. Now the thing is that all physicists or anyone, to be correct, always tries to study by analogy, and we will also apply this approach here. Gravitational force, you are already familiar with this. Gravitational forces, the force between any 2 point masses in this universe, and the force has a concrete mathematical form. Though our understanding of gravitational force is still not complete, it is just basic, and we know the universal law of gravitation is given by F is equal to g times of m1 into m2 by r square, when m1 and m2 represents mass of the 2 point objects that you are considering. Now you see, the force, gravitational force, is directly proportional to the product of the two masses, and the second point is, it is inversely proportional to the square of the distance between the 2 point masses. These two facts about gravitational force we know from our study. In class 9 also we have this chapter, and in class 11 also it is in quite details. Now, the new force that we are going to study in class 12 has a similar pattern. It is also directly proportional to Q1 into Q2. Now I have written directly Q1 into Q2, but what are they? We will come to that. Again, you see the similarity. The force is proportional to 1 by r square. So these are the two facts, or these are some of the facts which are basically similarities between this force and this force, or similarities between gravitational force and electric force. When there are some similarities, chances are there will be differences also, and differences should be clearly understood. Okay, first difference that I have written here is F is always attractive. Now what is F? F is the gravitational force between 2 point masses. It is always attractive. But in electric force, this force or the electric force may be attractive and also repulsive. Depends on some condition. We will come to that condition later. Second point, important point, gravitational force is medium independent. The gravitational force between 2 point objects is independent of the intervening medium. But the electric force between 2 point some things is dependent on the medium. Depending on the medium, it may be more, it may be less. I am talking about the magnitude of that electric force. Okay. So basically, gravitational force is one of the four fundamental forces. In class 11, we have come across four types of fundamental interaction. The first one is, or rather to say the most common one is gravitational force. Second one is weak nuclear force. Third one you can say electromagnetism or electromagnetic force. And the fourth one is strong nuclear force. These are the four type of interactions that we till now know. Out of this, already this has been studied in some details in class 11. But in class 12, our focus is on this force, electric force. Now, to study electric force, or the force between two somethings, first we have to know what is that something. Now, in case of gravitational force, F is equal to G times universal gravitational constant m1 into m2 by r square. What was this m1 and m2? If you recall, this m1 and m2 are masses. These are masses of what? Of some objects, point objects you can say, of some point objects. So these are masses of some point objects, correct? So this mass is what? This is a property. It's a property. It's a characteristic. Shown by whom? Shown by these two point objects. It's a characteristic. Exactly similarly, exactly you can say these Q1 and these Q2 that I have written here, already you know from your knowledge of class 10, these are charges. These are charges. Charges possessed by whom? These are also charges possessed by some body, some objects. Okay? Some objects. Now these charges, so this is a property that is possessed by somebody. So charge is a property that is possessed by some body. Okay, so the first point that is important is that charge is a property. Charge is a property that is possessed by a body. A body may be, that means any body can possess charge. Now, how is that charge produced in the body? How is a body charged? How is a body charged? How is a body charged? How do we charge a body? Or you can say how a body is electrified. How a body is electrified. Now the thing here is that for that we have to have a simple understanding of the structure of an atom. Let me draw a simple structure, the simplistic view of an atom. We have a positive core that is known as nucleus, and outside this nucleus there may be a cloud of, there is in fact a cloud of electron. Now, by convention this nucleus is said to be positively charged and this electron is said to be negatively charged. This you already know. So, in nature there is a perfect balance for a normal atom. You will see that the positivity of the nucleus is exactly equal to the negativity of the electrons. So the positive charges balance the negative charges. So as a result, the net charge of that particular system is 0. Net charge. Now the word net is important. Net charge of that particular system is 0. So the point to be noted is that the body has charges. Electron is negatively charged, this nucleus is positively charged, but the net charge is 0. Okay, the net charge of the system is 0. Whenever the net charge of a system is 0, that system is said to be neutral. That system is said to be neutral. Whenever a system has net charge equal to 0, the system is known as neutral, or the body is said to be neutral, whatever you want to say. Now, positively charged body. What is a positively charged body? Suppose you have this body and you rub it. By rubbing, what you are doing? There is friction between your hand and that particular object. If you can supply sufficient energy, what you can do? You can remove the outermost electrons of the surface atoms from the substrate. Some electrons from this surface of this substance can move onto your hands. Remember, just an example, electrons from the substance or the thing that you are holding in your hand may move to your own hand or some cloth, whatever you want to use. What I mean to say is that under friction or under some other process, electrons can be transferred from one body to another. Electrons can be transferred from one body to another. What can be transferred? Electrons. Electrons can be transferred. Electrons can be transferred from one body to another by various ways. Now, when you transfer an electron from, say, one particular substance A to another particular substance B, suppose there is a substance A, you transfer electron to substance B by some way. Some electrons are moved from here to here. Within this particular substance, there is a positive nucleus core. Since you are transferring electrons from this side to this side, you are disturbing the balance between the positive nucleus and the extranuclear electrons. When you disturb that balance, the body is said to be charged. When you disturb the balance between the electrical force between nucleus and electrons, the body is said to be charged. Remove the electron from this part to this part. Now, what is positively charged body? When you remove electrons from body A to body B, we say by convention, this body is said to be positively charged, this is said to be negatively charged. So you can note it like this. A positively charged body means it has a deficit of electrons. Deficit of electrons. And a negatively charged body means it has an excess of electrons. Excess of electrons. So positively charged body means deficit of electrons and a negatively charged body means excess of electrons in the most common sense. Okay, so whenever some electrons are transferred from one body to another, the body that receives the electrons becomes negatively charged and the body that gives the electrons becomes positively charged. Now, electron has mass, though the mass is very small. So remember, whenever transfer of electrons is taking place, the mass of the substances are also changing by a minute amount. In the next video, we will try to study the properties of or the characteristics that are shown by electric charge. What are the basic laws that they follow Okay, and after that we will go into details how a body is actually charged. How a body is actually charged. There are three methods. Generally there are two methods. One is friction and the other is induction. We will discuss this in our next video. Thank you for watching and keep washing your hands.